Hi, sixth graders, it's Mrs. Roop. We are finally going to look at this plate boundaries slideshow and notes that we have been talking about and seeing for the last few days. So what I'm going to do is I'm going to go through the slideshow and I'm going to click back and forth between the slideshow and the worksheet that you should have with you so that we can fill it out together. So make sure you're paying very close attention. So we've been talking about plate boundaries. We know there are three types of plates. There are two types of plates, continental and oceanic. But when those two types of plates come together, pull apart, or slide past each other, in other words, converge, diverge, or transform, you can have some pretty different land results. So we're going to dive into those and take a look. So we've got our 7 continents today: North America, South America, Antarctica, Africa, Europe, Asia, and Australia. And those are a result, scientists believe, of tectonic plates moving these land masses. Remember, originally they really believed that Pangea were all of these continents combined. So, you guys remember this fella, Mr. Alfred Wegener? He had this theory that the continents were all once connected and they were known as Pangea, but that they were drifting. He couldn't really explain, though, why it happened. So remember, all of his friends and all of the other scientists didn't believe him. They thought he didn't know what he was talking about. So after Alfred Wegener died in 1930, more research was done. And this fellow, Harry Hess, discovered that magma was rising from the seafloor and causing it to spread. Now, when the magma rose, it got from the mantle, it caused the spreading on the seafloor and thus the tectonic plates to move. So basically, Harry Hess discovered that the seafloor was spreading all because of those convection currents that we talked about. So we have Harry Hess's theory, Alfred Wegener's theory, and when we add them together, we get this big theory of plate tectonics that told us, hey, I think these plates really are moving. I think this is a possibility. So, the theory of plate tectonics. This basically tells us that the Earth's outer crust, remember the lithosphere, that's where the plates are held, are divided into several different plates that glide over the asthenosphere and form and cause the theory of plate tectonics. So we've got all these plates. And a fun fact, I know some of you asked on your 3-2-1 sheet how many plates there were. I believe there are 7 major plates, so 7 large plates, such as these, and then 8 minor plates, like the Juan de Fuca plate, the Cocos plate, the Caribbean plate, etc. So 7 big plates and 8 littler plates. So, reviewing, what causes these plates to move? The convection currents. Convection currents can transfer energy in the mantle. It causes that hotter magma to get hot, hot, hot and rise. Then it goes burr, cools off, and sinks back down into the lower mantle where it is warmed up again. As you can see, when it's doing that, it's pushing whatever is right here. Spoiler alert, it's the crust apart. And in a little bit, we're going to learn that this is seafloor spreading. Kind of interesting. So, when the tectonic plates are moving, they're going to do one of 3 things. They're either going to converge, come together, or collide. And hopefully with your hands right now, you are pulling them together, or at least you're imagining that. The second way is that they're diverging or dividing apart. And the third way is that they're transforming or sliding past each other. So let's look. What really happens when the plates diverge or move away from each other? So when we have an oceanic crust moving away from another oceanic crust, we're going to get a mid-ocean ridge, aka a mountain under the ocean. So when they're moving away, we're going to get a mountain under the ocean. So let's go back to our graphic organizer. When we have two oceanic plates dividing, the result is a let me make sure I'm mid-ocean ridge. An example of this would be the Mid-Atlantic Ridge. So I'm going to go over here. I'm going to write Mid-Atlantic Ridge. Mid-Atlantic Ridge is obviously in the middle of the Atlantic Ocean. And kind of a cool fact, the Mid-Atlantic Ridge comes above in through Iceland and is pushing Iceland apart. So when two oceanic plates diverge, we have a mid-oceanic ridge. It's also called seafloor spreading, and we're going to learn about that a little later. I don't want you to get confused with that. So make sure that your notes say mid-ocean ridge and mid-Atlantic ridge. Now, when two continental crusts, two land crusts, move apart, they're going to create a rift valley. A rift valley. So let's go over here. The result is a rift valley. And the example is the Great Rift Valley, and that's in Africa. Now, I strongly encourage you, Great Rift Valley, you can see, so I'm going to write in Africa. I strongly encourage you to Google the Mid-Atlantic Ridge and the Great Rift Valley to see what they look like, because they are amazing. Now, in the the Great Rift Valley in Africa, water is going to eventually fill this valley, but that's going to take millions and millions and millions of years. Okay, so divergent. When we have two oceanic crusts, we're going to get a mid-oceanic ridge. When we have two continental crusts diverging, we're going to get a rift valley, and they're moving apart. Let's talk about when they converge. So when they're converging, we can have two oceanic plates converging, we can have two continental plates converging, or we can even have a continental plate and an oceanic plate meeting up against each other. So the first type, when we have a convergent boundary and it's an oceanic versus an oceanic boundary, so two oceanic plates are bumping up into each other, we're going to call that a subduction zone, because the older oceanic boundary is going to go underneath. It's going to create a volcanic arch of islands. So if you look here, like the Aleutian Islands, these were all created because two oceanic boundaries were colliding and one went under. You can see here's a plate, here's a plate. They're colliding right here. One's going under. And there's a bunch of other stuff that's happening, but for the most part, what you need to know is that a volcanic arc of islands is being created. So we're in converging, coming together. If two oceanic plates converge, we're getting a volcanic of islands. And our example are the Aleutian Islands in Alaska. Now again, I encourage you to Google these because they are so cool to look at, especially if you haven't seen them before. Aleutian Islands, A-L-U-E-E-U, in Alaska. So when two oceanic plates bonk into each other, we're going to get volcanoes that'll eventually form islands. All right, second type of convergent boundary is when two continental or two land plates push against each other. So two continental crusts collide when they push against each other. The pressure causes both plates to go up to create mountains. So if you look here, we've got a plate coming, we've got a plate coming, we've got all that pressure. It pushes up those two plates, and we have a mountain. An example would be the Himalayan mountains. So let's go over here. When two continental plates converge, our result is folded mountains. And our example would be the Himalayan mountains. I'll leave that up for just a second so that you can copy it. Okay, the third type of convergent boundary, hopefully in your head you're thinking continental versus oceanic, or the opposite, oceanic versus continental. In this type, we know that the oceanic crust is going to go below the continental crust because it's more dense. So what's going to happen is we've got the oceanic plate going under, volcanoes are forming right here, and then we've got a trench forming right here. Old crust, the old oceanic crust that goes down here is just destroyed. It's melted because we know the asthenosphere is really, really, really hot. Some examples of these, or an area where this happens, is the Cascade volcanoes in Washington, Oregon, and California. So if you look here, we have California, Oregon, and Washington. All of these mountains and volcanoes were created because of an oceanic and continental crust collision. So, when we come over here, the result of oceanic and continental plates converging would be volcanoes and trenches. And our examples would be the Cascade Mountains in Washington, Oregon, California. I'll give you a second just to get that copied down. All right. We've talked about divergent. We've talked about convergent. Our last plate boundary type that we need to talk about is transform. Plates are slipping past each other all the time, and when these transform boundaries are happening, we have earthquakes that are caused. When they're slide passing each other, and I'm hoping you're doing that thing with your hands where they're just going past each other, crust isn't being created and it's not being destroyed. They're just moving right past each other, no problem. But it is causing earthquakes. A lot of these are found on the seafloor of the ocean. And the most famous transform boundary is the San Andreas Fault in California. This is a picture of it right here. So, back to our notes. Any two plates that slide past each other, we're going to result with earthquakes. An example would be the San Andreas Fault in California. I wish I was a better speller. Andreas. So your notes should be filled out like this. My hope is that you guys will take some time to review and understand that when two oceanic plates diverge, we get mid-ocean ridges. Will you have to know the examples on your test? Not test, but your learning check tomorrow? No. You might not even have to know, well, I don't know what's that. You won't have to know examples by any means, but it definitely doesn't hurt. So if you want to quiz somebody or quiz yourself, that might be very helpful. Let's go ahead and look at the remainder of the slideshow. We're almost done. The Ring of Fire, we've talked about, I think it was brought up with the Generation Genius activities that we did. The Ring of Fire is a long chain of volcanoes that surround the Pacific Ocean. So if you look closely, here's North America. California is like right here. We've got this whole area that's highlighted in red. We call that the Ring of Fire. It is one of the most geologically active areas on Earth when it comes to volcanoes. So basically, when people move around these areas, they should be aware that there will more than likely be lots of earthquakes and more than likely be a lot of volcanoes. And these are just because there are a lot of plate boundaries around here that are converging, diverging, and transforming. All right, sixth graders, that's going to wrap us up with this slideshow. What I encourage you to do is make sure your notes are obviously filled out. Put your name at the top. You're going to take a picture of this. You're going to go into Canvas. You're going to go into Science. You're going to go into Module 1. You're going to go into the newest assignment that you have called Plate Tectonics Slideshow and Graphic Organizer. It's due tonight. It's worth 3 points because there are 3 different types of plate boundaries that I wanted you to write down. It says grab an organizer, watch the video below, which is this video. You're going to take a picture and upload it to this assignment. When you're done, I want you to review your notes in your science folder just to make sure that you are ready to go for tomorrow's learning check. Don't freak out, that learning check's 10 questions. If you're able to complete the GIN kit with relatively no problems, you're going to do wonderful. I'm looking forward to seeing you guys soon. Hope you have a great day. Bye.